Phishing detection. What is phishing? Phishing is a fraudulent social engineering attack. Extraction of confidential information are the primary aim of phishing scams. It is also referred to as automated identity theft, as the confidential data gained through such scams are used to create fake identities. Motivation behind such scams are financial gains or to damage reputation of an organization. Defense mechanism. Taxonomy of defense against phishing attacks is broadly classified into user education and software-based defense approaches. The user education refers to spreading awareness and education about phishing among internet users. Many education-based approaches have been proposed in literature. The software-based defense approaches include network-level protection, authentication mechanism, client-side tools, and server-side tools. Amongst these approaches, phishing detection by using data mining is widely being accepted and used by researchers because this method yields good level of accuracy. Also, phishing detection by using multi-layered approaches where multiple classifiers are used to improve the detection of phishing emails has been widely used by researchers. Feature-based approaches. Features to detect phishing include body-based features, subject-based features, sender-based features, script-based features, and URL-based features. The body-based features are extracted from the email body itself, example presence of a form or certain phrases in the email body. The subject-based features are extracted from the subject of an email, such as whether it is a reply to a previous mail or it checks for the presence of certain kind of words in the email body such as verify, debit, etc. URL-based features check whether an IP address is used instead of a domain name. The script-based features. These features check for the presence of JavaScript, pop-up window code, or on-click events, etc. in the mail. The sender-based features include sender details such as difference between the sender's address and the reply to the address. All these features have been used because they give higher accuracy of detection. The proposed approach focuses on feature extraction and classification using machine learning algorithm. The features extracted will be keywords, IP addresses, grammar analysis of the email body, script, HTML, and number of links. These extracted features will help the machine learning classifier to discriminate between phishing and legitimate emails. These features have been selected as they have higher information gain ratio, which shall assist the machine learning classifier to detect phishing emails. For grammar analysis, the mail body text will be normalized using the following process. Initially, the email body will be the input. It shall be normalized for analysis. Normalization of text is done so that the semantic meaning of text can be brought into acceptable level. Apache Lucan, which is an open source information retrieval software, will be used for text normalization. The search functionality of Apache Lucan are very advanced and so are its indexing capabilities. A database of WordNet set of SciNets will be created in MySQL and will be linked to the Apache Lucan. WordNet is a large lexical open source database of English verbs, nouns, adverbs, and adjectives, and also it is freely available. Email tokenizer is the next in the chain. Its task is the removal of URL terms in the email. This is done because the URL contains characters and words that have no semantic meaning, and so therefore it has no role in the grammatic feature. Letter tokenization aids in extraction of words individually. Each word is considered as a token. Stop filter does the task of removing duplicates and common words. This helps in increasing the computing speed as less words would be looked up in the dictionary or the corpus database while analyzing grammar. Also, all the non-English text shall be removed in this phase. Case stamping is implemented so that the elementary root of words can be recovered. For example, checking and checked is converted to check, following and followed is converted to follow, and so on. The result obtained from case stamp is compared with MySQL database of WordNet. This process is very fast as the indexing and searching capabilities of Lucan are very efficient. On finding a match, the incisive searching is stopped. But if a match is not found, an anomaly would be triggered and the sentence would be termed as grammatically incorrect. The output which is received from the text normalization should be converted back to the original sentence. This is the new input for grammar analysis. Next phase is part of speech tagger of sentences. Assignment of morphosyntactic features will be done in this phase. For example, identification of verbs, nouns, adjectives, adverbs, etc. Sanford tagger will be employed for it. The source of corpus will be Wikipedia, as it has large number of structured articles. So all the bigrams that will be generated from the Wikipedia will be stored in MySQL database. In the bigram matching phase, the bigrams from the received sentences and the Wikipedia will be matched. If a bigram is found, we move to the next sentence, and if the bigram does not match, the sentence is deemed to be grammatically incorrect. Feature extraction process. The feature vector would be extracted by using Java Mail API. The email is converted into an internal email object so that the email components can be extracted easily. Thus, by doing so, the required features such as IP addresses, HTML, number of links, script, keywords can be detected and thus extracted easily. The proposed model for phishing detection has three main phases, which are pre-processing of data sets, feature ranking and crisp value, and finally, applying classification technique. In the pre-processing stage, feature parsing and stamping will be done, and the features that represent the email as a phishing email will be extracted. In the next stage, information gain and crisp value will be calculated to help the classifier discriminate better between phishing emails and a legitimate email. SVM classifier will be used to classify phishing and legitimate emails. In this phase, we'll be using 70% of the email datasets for training the classifier and the rest 30% for testing it. The evaluation of the results will be done by taking into account accuracy, false positive, false negative. Thus, we believe that this approach shall be able to attain better accuracy and detection of phishing emails. Thank you so much for listening.